Ever looked up at night and thought, wait a minute, with all those stars up there, how come it's not brighter?
Yeah, it's a really good question.
It's kind of weird when you stop to think about it, right?
Totally.
It's a question that puzzled astronomers for forever, actually.
Mm.
And it's called Olbers' paradox, which sounds pretty fancy, right?
Yeah, definitely.
Well, today we're going to try to shed some light on it.
Okay.
And we'll be using this cool article called Stars Are Everywhere, So Why Is the Sky Still Dark? By Brian Jackson.
That's good.
Have you heard of this one?
Oh, yeah. It's a great one. Really makes you think about just how huge space is and how we can get tricked by what we think we see,
Yeah, that's so true. Our brains can only handle so much.
Right.
So where do we even start with this whole paradox thing?
Well, the article kicks things off by asking us to picture this bubble around Earth.
Okay.
And then we imagine it getting bigger and bigger, like swallowing up more and more stars as it goes.
Oh, I like this. So like blowing a soap bubble and watching it grow.
Yeah, kind of like that, except with way more stars than soap, obviously.
Yeah, of course.
But here's the thing. Even though each star gets dimmer the farther away it is, the total number of stars in that bubble should be making the sky crazy bright, at least in theory.
So like if you keep adding more and more tiny lights to a room, eventually the whole place is going to be lit up.
Exactly, but when we look up at night, it's not like that at all, is it?
Nope, definitely not.
So that's the paradox. The logic just kind of breaks down.
Huh. Okay, so then what's going on? Why isn't it a giant wall of starlight?
Well, one of the first things the article points to is that the universe, it's not actually infinite.
It's not. I always kind of assumed it just went on forever.
It's big, that's for sure, but it's not forever.
Okay, so how old is it then?
About 13 billion years old.
13 billion. Wow, that's like way more years than I can even imagine.
It is a long time, yeah.
But it's not forever, huh?
Nope, and that's actually a huge part of why we don't see that wall of starlight.
Okay, how?
Well, because it means there's a limit to how far we can actually see.
A limit.
Kind of like light from stars farther away than 13 billion light years.
Yeah.
It just hasn't had enough time to get to us yet.
Oh, I get it. So even if there are tons more stars out there, their light's still on its way.
Exactly.
Like a cosmic delivery service that takes billions of years.
Kind of.
So it's like we're looking at a super old photo of the universe.
In a way, yeah, we're seeing it as it was billions of years ago.
Whoa. That's trippy.
Right.
But okay, so even with the age thing, there should still be a ton of light reaching us from within that 13 billion light year bubble, right?
Yeah, you'd think so, but there's another piece to this puzzle.
Another one. Okay, lay it on me.
You see, the universe, it's not just sitting still. It's actually expanding.
Expanding, like
Yeah.
getting bigger all the time.
Yep, and it's happening faster and faster, too.
Huh. Okay, but how does that affect the starlight? Is it like blocking it somehow?
Not quite. It's more about what the expansion does to the light itself.
What do you mean?
Think about sound for a second, like a siren on an ambulance. You know how the pitch changes as it drives by?
Oh yeah, it gets higher coming towards you and then lower as it goes away.
Right. That's the Doppler effect. And something similar happens with light.
With light, how does that work?
So as galaxies move away from us, the light waves they give off gets stretched out.
Stretch.
Yeah, like pulled out longer. And that shifts their color towards the red end of the spectrum.
So like the universe is literally stretching the light, making it redder.
You got it.
I had no idea.
And that stretching, it's called redshift. It's how astronomers figure out how far away things are.
So the color of the light can tell you the distance. That's crazy.
It is pretty cool.
And the farther away a galaxy is, the faster it's moving away and the redder the light gets.
Exactly.
But wait, if it keeps getting redder, what happens?
Well, here's where it gets even wilder.
Okay, I'm ready.
For the really, really far away stuff, the light gets stretched so much that it goes completely out of the visible spectrum.
Wait, you mean it becomes invisible?
Yep, it gets pushed into the infrared, which our eyes can't see.
So even if that super distant starlight did reach us, we wouldn't even know it.
Pretty much. It's like a cosmic invisibility cloak.
Whoa, okay, this is blowing my mind.
Haha, glad you're enjoying the ride.
So hold on, let me get this straight.
Sure.
We've got the age of the universe limiting how much light has reached us, right?
Right.
And on top of that, the universe's expansion is stretching the light from those faraway galaxies, shifting it into invisibility.
You got it.
Wow, so even though we look up and see darkness, it's not really empty, is it? It's like a hidden light show our eyes just can't pick up.
Exactly. There's a whole lot more going on out there than we can see with just our eyes. So yeah, there's more to it than just distance,
Okay, so we've got distance, we've got the age of the universe thing, and this redshift thing, it's all starting to click, but man, this is some complicated stuff.
Yeah, it is. But think about it this way, like, it really shows us that the universe isn't this boring backdrop.
Yeah.
It's alive, it's changing, it's constantly on the move.
That's a good point. It's like we're trying to understand a whole movie by just looking at one single frame.
That's a great way to put it. And like a movie, the universe has a history. And that history is written in the light that comes to us from all those stars and galaxies far, far away.
Speaking of history, the article mentioned different kinds of redshift. Is that what you're talking about?
Exactly. There's the one we talked about, cosmological redshift, from the universe expanding.
Right.
But there's also gravitational redshift. That's from like really heavy objects like black holes. Their gravity's so strong it can actually pull on light.
Whoa! Seriously?
Yeah, and then there's Doppler redshift. That's the one we talked about with the ambulance siren. It's all about things moving towards or away from us.
So it's not just one size fits all. There are different flavors of redshift.
You got it. And by looking at these different types, astronomers can map out like the whole structure of the universe, how galaxies are moving, even stuff like dark matter and dark energy.
Wow, so much information packed into just the color of light. That's amazing.
It's pretty incredible, right?
Yeah.
It shows how much we can learn by just paying attention to these little clues, like the universe is whispering secrets to us if we just know how to listen.
I like that. The universe whispering secrets is awesome.
It's a testament to both the power of science and the creativity of all these brilliant astronomers out there who are figuring it all out.
Right, they're like cosmic detectives.
Exactly.
So to bring it back to our big question, why is the sky dark? It sounds like the answer isn't just one thing, it's a whole bunch of things working together. The age of the universe, the expansion, the red shifting, right.
Exactly. And once you put all those pieces together, Olbers' paradox isn't really a paradox anymore.
Yeah, it's more like we were missing some information. Like, we thought the universe was one way, but it turns out it's way more dynamic and complex.
Right. It's like we were looking at a flat picture, but then suddenly it pops into 3D.
I like that. It goes from flat to 3D, and suddenly it all makes sense.
And that's why the night sky isn't just a blinding wall of light. It's a balance between all these different forces and factors.
So what we see as darkness is actually full of, like, hidden information, like echoes of the universe's history traveling for billions of years to get to us.
Exactly. It's pretty mind-blowing when you think about it.
It is, totally. Okay, but you mentioned earlier that our view of the night sky, it's limited by, like, our own biology. What did you mean by that?
Oh, yeah, good point. So our eyes, they can only see a teeny tiny sliver of all the light that's out there.
Really?
Yeah, we call it visible light, but it's just a small part of the electromagnetic spectrum.
The what now?
The electromagnetic spectrum is like this giant rainbow of light, but we can only see the ROIGBB part, red, orange, yellow, all that.
Oh, right. So there's a whole lot more light out there that we're just completely missing.
Exactly. There are radio waves, microwaves, infrared, ultraviolet, X-rays, gamma rays, all kinds of crazy stuff.
And it's all light, just different wavelengths.
You got it. And each type of light can tell us different things about the universe.
Wow. So there could be all kinds of things happening out there, sending out light in these other wavelengths, and we have no idea.
Exactly. Which is why astronomers have all these cool tools and telescopes that can see those other kinds of light so we can get the full picture.
It's like we're only listening to one instrument in an orchestra when there's a whole symphony going on.
Perfect analogy.
Yeah.
And by tuning into those other instruments, those other wavelengths, astronomers have found all sorts of crazy stuff like pulsars and quasars, and even the cosmic microwave background, which is like the afterglow of the Big Bang itself.
Whoa. Okay, so if we could see the whole spectrum, like all the different kinds of light, what would the night sky look like then?
Oh, man. That's a great question. It'd be way more colorful and complex than what we're used to, that's for sure. We might see the faint glow of galaxies so far away that their light's been stretched into the infrared, or the intricate shapes of nebulae where stars are born and die. We might even see the remnants of supernova explosions, all lit up with X-rays and gamma rays.
I can't even imagine. It sounds incredible.
It'll be a wild light show, that's for sure.
So even though it looks dark to us, the night sky is actually bursting with invisible light and energy.
Exactly. It's a good reminder that there's always more to discover, more than meets the eye, literally.
I love that. It's like a whole hidden universe just waiting for us to unlock it.
And who knows what amazing things we'll find when we do.
Makes you wonder if, like, the night sky will always look this way,
That's actually what got me hooked on astronomy in the first place. The universe isn't static. It's always changing, always evolving. So, yeah, our view of the cosmos is definitely going to change over time.
So it's like a super slow motion movie unfolding over billions of years. What would people see, like, millions of years from now?
Well, as the universe keeps expanding, more and more starlight will eventually reach Earth. Those dark patches we see now, they might slowly fill in with the light from distant stars and galaxies.
Wow, that's wild. Future generations could be looking up at a totally different night sky than what we see.
It really puts things into perspective, doesn't it? Like how vast time and space are, and how our little slice of existence is just a tiny blip in the grand scheme of things.
It really does. This whole deep dive has been so fascinating. We've learned that the darkness of the night sky isn't just the absence of light. It's this crazy mix of things. The age of the universe, the expansion, the red shifting, even our own limited way of seeing things.
And it all comes back to that one simple question: why is the sky dark? It's amazing how something so basic can lead to such profound discoveries.
It really is. It shows how much we still don't know, how much there is left to explore.
Exactly. And for our listeners who want to learn more, that article we've been talking about, Stars Are Everywhere, So Why Is the Sky Still Dark? By Brian Jackson, it's a great place to start.
We'll make sure to link to it in the show notes.
And remember, the next time you look up at the night sky, don't just see darkness. See a universe brimming with mystery, with history, with endless possibilities.
Beautifully said. And on that note, we'll wrap up our deep dive into the darkness of the night sky. Until next time, keep looking up and keep those questions coming.